So what is electrochemistry? The particular reaction that we were discussing is oxidation and reduction. And as you might remember, I give you this example. This example, we said if you place a copper wire inside the solution of silver nitrate, you are going to see formation of crystals of silver over the copper wire. Eventually, the copper wire is going to dissolve to make this blue solution, and the metal form of silver is formed over as these crystals. All right, we want to look at this reaction further and see what is happening, and I'll be introducing what is called activity series. So this is the chemical equation which shows the redox reaction inside this beaker. So what we said is this is copper wire, this is silver nitrate inside the solution. The reaction resulted to the formation of silver metal and copper was dissolved. So what is happening in this reaction is simply that copper is losing electron. Copper is losing electron, gaining two positive charges, and silver is gaining electron to become Ag+. So what we are saying is this, that both metals in here, both metals, Ag on the right-hand side and copper on the left-hand side, these are both apparently metal. They can give electron, but apparently copper is a better electron donor. It can donate electrons to silver ion, and silver ion can be reduced to silver metal. So on the left-hand side, I have one metal and one ion. On the right-hand side, I have one metal and one ion. Just compare the two metals on the left and the other one on the right. We say copper has the ability to give electron to the ion of silver to produce silver metal. So any metal which is able to produce another metal from its ion, it's a better electron donor. So we say Cu is better electron donor than Ag, and as a result, I can say that Cu has higher activity than silver metal. So, in other words, if I ask you this question, if I react silver with copper ion, is silver going to be able to produce copper metal from its ion or not? Another word, between the two metals, which is better electron donor? Is it silver metal or copper ion? Well, between these two reactions, we said the first one obviously happened while you see it by your eyes. It has happened in the lab. That means Cu is a better electron donor than Ag. So Ag is not able to give electron to copper. Ag is not able to produce copper metal from its ion. So this reaction is not going to happen spontaneously, but the opposite reaction, which is the reaction on the top, will happen spontaneously. So what is activity series? If we react these metals with another ion, react a metal with ion of another metal, run the experiment, make observation, and decide between two metals, which one of them are better electron donor, we come up with this table. What is this table telling you? It's telling you lithium is a better electron donor than potassium. Potassium is a better electron donor than barium. So a strongly reducing agent. That means agents which have the ability to give electron. They are coming on the upper part of this table, and on the bottom part of the table, We are going to see that the metals which are on the bottom, they are not as good electron donor, but they will accept electron better. Their ion will accept electron better. So as you see, lithium has higher activity. That's what we say. This is activity series, higher activity. That means lithium is excellent electron donor. And we know that these elements, they are so reactive, they can react with water, and they can give electron to water to produce hydrogen gas. As we go to second category, these are not as strong as first category, but they are electron donors. And next category, they are weaker electron donor. Until we use hydrogen as a reference. Elements which are above the hydrogen have got higher ability based on their location in this table of donate electrons. These metals, usually their ion are excellent acceptor of electron, but they are not, the metal are not a good electron donor. So as a result, any element higher in activity series will reduce the ion of any metal in lower activity series. That means if I compare silver with copper, silver cannot give electron to copper ion, but copper can give electron to silver ion to produce silver metal from its ion. So any metal which can produce another metal from its ion is more active. It's better electron donor. So we say it has higher reduction potential, and we are going to discuss potential ability of giving electron, reduction potential. We are going to discuss this later on in general chemistry. Okay, so this is the same table. It looks a little different. I thought I better show it to you. So these elements are greatest electron donors. They react rapidly with hydrogen ion and water to produce hydrogen gas. These are electron donor. These are good electron donor. They can give electron to hydrogen ion from acids and make hydrogen gas. The third category, which is less electron donor, it has less ability of electron donation. They react with hydrogen ion to release hydrogen, but you need some heat. And these elements do not react with even hydrogen ion to make hydrogen gas. So activity is decreasing as we go down. The ability of giving electron is increasing as we go up. So we call this strongly reducing. That means they have the ability of give electron and cause reduction of other ions. All right. So I'm going to use this table. So we are asking you compare the relative activity, relative ability of donate electrons, and decide which one of these reactions is going to happen spontaneously and which one is not going to happen. Well, all you have to do is compare the two metals. There is one metal on the right and there is one metal on the left. If the metal on the left has higher activity, that means if this metal is above Cu in the table of activity series, reaction is going to happen spontaneously. So let's check. Where is iron and where is copper metal? Copper metal is here. And iron is above copper metal. So iron can give electron to copper ion and produce copper metal. So this reaction is going to happen spontaneously. And let's compare the two metals on the left and right of this equation is this reaction going to happen or not? So what I see is zinc, compare zinc to copper. If zinc is at higher location in activity series, reaction is going to happen. So what I'm going to do is zinc above copper metal or not? And let's see, zinc is here. And can you find copper metal? Yes, copper is below, zinc is above copper metal. Zinc is better electron donor. So zinc can give electron to copper +2 and can produce, so this reaction is going to happen spontaneously. How about the third equation? I'm comparing activity of copper against silver. For this reaction to happen, copper must be at higher activity level. Is copper higher than silver? Yes. So this reaction is going to happen spontaneously as well. How about the fourth one? For this reaction to happen, I have to compare. I don't have a metal here, but I have an element. So I have to compare the two elements, magnesium and hydrogen. Is magnesium at higher activity than hydrogen or not? So this is hydrogen. And magnesium here. So magnesium is at higher activity relative to hydrogen. So yes, this reaction is going to happen spontaneously as well. How about this one? If I'm going to decide, is it going to happen or not? All I have to do, compare the two elements. One element on the left, silver metal. Another copper metal. Let's look at the location of these two metal and see which is at higher level. Is silver at higher level of activity or not? So this is silver relative to copper. Silver is at lower activity. Silver does not have the ability of give electron to copper ion. So no, this reaction is not going to happen. It's not a spontaneous reaction. That means it doesn't happen by itself. All right. And if I go to the next slide, again, I'm asking you which one of these reactions is going to happen. The one which has copper has higher activity than silver. This is going to happen. And that means the opposite of this reaction is not going to happen. This is not going to happen. In other words, if I add silver metal to copper ion, I'm not going to be able to make ion. But you already observed that when we place copper wire to silver ion, you saw formation of crystallized silver metal. Okay, so let's do this problem. We are asking you, look at these reactions. So let's see if we can answer this problem. The question is, which one of these four reactions are going to happen? Which one of these four reactions below we look at? Well, again, I have the activity series for you. All you have to do on the left-hand side, take the element, not the ion. Compare the elements, platinum, hydrogen. If platinum is at higher activity in activity series, reaction will happen. Is platinum, is it higher than hydrogen? No, it's below hydrogen. This reaction is not going to happen. If I want to decide whether this other reaction is possible, again, on the left-hand side, I have only one element, and that element is an I. And the other element on the other side is hydrogen. Is nickel at higher activity relative to hydrogen? So this is nickel, and this is hydrogen. Yes, so this reaction is going to happen spontaneously. Number two. Number three, What is the element on the left-hand side? Hydrogen. What is element on the right-hand side? Sn. Is hydrogen at higher activity relative to Sn or not? So this is Sn. This is hydrogen. Hydrogen is at lower activity relative to Sn. So hydrogen is not able to give electron to Sn plus 2 to make Sn. So this reaction is not going to happen. And if I look at the bottom reaction, the element is Au. On the other side, the element is Ni. Is Au at higher reactivity relative to Ni? Then reaction is going to happen. Au and nickel, no, Au is not at higher activity. So Au is not going to be producing Ni from its cation. So does this make sense? No. Number two, Ni and hydrogen, Ni and hydrogen, yes. So all of them can happen except the last one. No. I'm sorry. All of them can happen except the second one. All right. Now, these three reactions which are shown on the right-hand side, these are happening. Now, we want you to compare the activity of these methods and come up with one equation which is correct. Which one of these 5 equations are correct? That's the question we're asking. What is, if I look at aluminum relative to zinc, if reaction is happening spontaneously, is it saying that Al has higher activity than zinc, right? Is this the conclusion from reaction number 1? Look at reaction number 2. Is it suggesting that magnesium has higher activity than Al? So can I write here, if my pen helps, magnesium is at higher activity than Al, right? And let's take a look at reaction number 3. If reaction is happening, it simply means that zinc has higher activity than copper. So I write here, zinc has higher activity than Cu. Now, let's combine these 3 together. So, is this suggesting that Al is stronger than zinc? Higher activity than zinc. And if I use this, zinc at higher activity than copper. And magnesium has higher activity than Al. So I write here, magnesium has higher activity than Al. So if I combine these, I get this result. Which one of these results is agreeing together, can I say? Number 1 is the answer to this question. Do that make sense? I hope these make sense. If they do not, please come and see me so we can discuss it during my Zoom hours. Okay, I think this is a good point to stop, and I will continue later. Let's do this and discard all the signs, and I'm going to stop. I will have to stop being on the Zoom, and this is the Zoom, and this is the Zoom bar, and where is the Zoom bar? I'm looking for a Zoom bar, and let's say, and